Hi, my name is Joe Perfetti. I'm a professor of finance, and today I'd like to talk to you about the time value of money. Have you ever wondered how finance people are able to compare cash flows that are received at different points in time? So for example, let's say we're going to get a bunch of money 5 years from now or 10 years from now. How do we evaluate what it's going to be worth today? That involves applying principles called the time value of money. And that's what we're going to discuss here in this video. In order to make those adjustments, to move the cash flows and the values between periods, we need to understand three major factors. First, how much cash are we talking about? Second, what is the interest rate that's going to be applied to the cash flow over time? And third, how many years or periods away is that cash flow from today? If we know those three things, then we can adjust to the current period to get what we call a present value of a cash flow that we received in the future. Or if we have some cash we invest today, we can look at what's called the future value, or what that cash will eventually be worth in the future. Those are the core principles associated with the time value of money. So let me start out with a simple example. Let's say we have $100 today, and we want to invest this $100 at a 6% rate of interest, and we want to find out in 3 years, how much will that be worth? Well, that's a concept known as future value, and here's what we would do. First, we would draw a very simple timeline, and you can see the bars behind me representing the timeline. And basically what we would say is in the first year, we'd earn 6% interest, so $100 would turn into $106. In the second year, we would get interest on the interest, an impact called compounding. So our $106 times 1.06 would actually get us to $112.36. In the third year, our $112.36 would grow another 6%, so we multiply by 1.06 again, and we'd end up with $119.10. So the future value in 3 years of $100 invested at 6% annualized interest is $119.10. This illustrates also another important point called compounding, or compound interest, which is not only do we earn interest on our investments, but we actually earn interest on the interest. And over time, that compounding effect can really cause our money to grow. So if you look at this chart, you'll see that if we invest money at 10% for over 20 years, that what's going to happen is by year 20, we've actually made more money on the compounded interest than on the principal and the actual interest payments combined. Compounding is a very important and very powerful force in finance, and it must be applied when we think about the time value of money. So let's go back to some principles that will help us understand how to move the values of these cash flows around. These are going to be called the 3 rules of time travel, and they were developed by Burke and DeMarzo. And the 3 rules are as follows. Rule number 1, we can only compare 2 values at the same point in time. Otherwise, we're comparing an apple and an orange. Rule number 2, in order to move a cash flow into the future, we must compound it based on the number of periods. Rule number 3, in order to take a cash flow we receive in the future and bring it back to the present or today, we must discount it. And those are going to be the 3 rules that we're about to apply. So let's start out with that second rule. How do we look at the value of what will happen to our cash flow into the future? That is a concept known as future value. And you can see the formula on the screen for future value, that the future value of any cash flow is the cash flow today times 1 plus the expected interest rate, which is R in the formula, to the power of n, which is the number of years or number of periods that you're going to invest over time. So let's say we wanted to know the value of $5,000 invested today at 10% interest and what that value would be in 5 years. So if we put that into the formula, cash flow would become $5,000. R, the interest rate, would be 10%, and 5n years, 5,000 times 1.1 to the 5th power would be the mathematical way to solve it, and that would get us an answer of $8,053. So we're going to draw a simple cash flow timeline on the screen. Today, we represent as time 0. And each period, each year, is going to be 1, 2, 3, 4, and 5. So we're then going to put the cash flow that we invest today, $5,000, at time 0. And this is growing at 10% a year. So between time 0 and the first year, growing at 10%, we multiply by 1.1. So by the end of the first year, we'll have $5,500. We then reinvest the $5,500 at 10% to get to year 2. So we multiply by 1.1 again. So that gets us to $6,050 in year 2, compounding the interest. To get to year 3, we multiply by 1.1 a third time. So again, that turns into $6,655. To get to year 4, we multiply by 1.1 a fourth time. That gets us to $7,321. And finally, to get to year 5, we multiply by 1.1 a fifth time, and that gets us to $8,053. So with the timeline, we can actually see what's happening more distinctly than the formula. But the idea is that money will grow over time and we will get interest on the interest, so that again, the future value of $5,000 in 5 years is going to be $8,053. What if we wanted to go in the other direction? Take cash that we receive in the future and bring it back to today. That's a concept known as present value. So let's do a second example with present value in mind. In this case, let's say we're going to receive $20,000 in 5 years, and our expected rate of interest is 15%. Well, the formula for present value is we take the cash flow and we divide it by 1 plus the interest rate to the number of years as a power. So in this case, we take the cash flow of $20,000 divided by 1 plus 0.15 or 1.15 for the interest rate to the fifth power, because we're receiving that cash flow in 5 years. If we were to look at that on a timeline, we could put on year 5, $20,000, and we want to come back to today or time 0. In either case, we're going to end up with an answer of $9,944. So let's walk through the timeline process. If we take $20,000 and we divide by 1.15 to get from year 5 to year 4, we end up with a year 4 value of $17,389. If we divide by 1.15 again, we get a year 3 value of $15,121. If we divide by 1.15 again, we get a year 2 value of $13,149. If we divide by 1.15 again, we get a year 1 value of $11,434. And if we divide by 1.15 a final time, we get $9,944. So again, the present value of $20,000 received in 5 years at a 15% interest rate is $9,944 today. That's what it's worth to us today. As a matter of fact, we could have gone in the other direction, which says if we take $9,944 and we invest it at 15% for 5 years, it will grow to become $20,000. And so we could be indifferent between the two. $20,000 in 5 years is worth a little under $10,000 today. In finance, we often think in terms of present value because it's much easier to think in terms of current dollars than future dollars. So you will often see most cash flows converted into a present value format. The nice thing is once the cash flows are in the present value format, they can be added or subtracted against each other, regardless of the time period in which they are earned. Little terminology. I've been using the concept of interest rate. Internally to the business, people might also refer to this as something called the hurdle rate or the expected rate of return. Externally, it might also be called the cost of capital. And you might hear people refer to it as the discount rate. These terms are fairly interchangeable in finance when it comes to time value of money. It's the R in the equation, or again, the risk-based expected rate of return that we are either going to invest the money or in which case we're going to bring the money back. So I've been using the concept of interest rate, but you may hear people refer to this as hurdle or discount rate within the firm. Another way of thinking about this, to kind of visualize what's happening in the formula, is to create what we call a discount factor table. So using the concept of present value, we're going to actually create a table applying the formula based on $1 of cash flow, and we're going to use interest rates across the columns, and we're going to use number of periods or years down the rows. So what that will allow us to do is to see the value today of $1 n years in the future, down the rows, at whatever interest rate we want to apply. So, for example, let's say that we're going to get $1 10 years from today, and our expected rate of interest is 7%. That means, applying the formula, and you can see this on the table, $1 in 10 years at 7% is worth 51 cents today. And in 10 years, if the interest rate were to change to 10%, that same dollar would only be worth 39 cents. And if we were looking at a really risky project and that interest rate or hurdle rate were 25%, $1 received in 10 years would only be worth 11 cents today. So obviously, time matters to the present value, as does the expected rate of interest. And as we go longer, and as it takes us a higher level of risk, then you can see the cash flows are worth less and less to us today. By the way, the opposite is true if you're spending money, meaning if you defer money into the future that you spend, it doesn't cost you as much in present value terms to spend money in the future. That's the concept, again, of time value of money. So let's close out by going back to our original example of present value and use the discount factor table to get to the same solution. So in this case, $20,000 that we receive 5 years from now at a 15% interest rate or discount factor. So what we're going to do is this table, by the way, just for the previous example, was shortened to 2 decimal places, but I'm actually going to expand it to 5 decimal places just to make sure that we get a higher level of accuracy. So in this case, we look down 5 years, we look across to 15%, and we see 0.49718. So that's called the discount factor. So what we do is we multiply the 20,000 by 0.49718, and we get a result, $9,944. So the discount factors are just a simple way where instead of actually doing the math in the formulas, the math is kind of done for you, and you can just apply the discount factors to the cash flow to turn cash flows into present value. These are some core concepts of time value of money.